When we were using our UITableView, we had our view controller implement both the UITableVIewDelegate and UITableVIewDataSource protocols. We need to remember that the Datasource protocols were responsible for setting up how our table view looked in terms of how many cells we had, how many sections we had inside of our table view, how many rows were in each of the sections, and what our UITableView cells looked like and what information they displayed. Our delegate was responsible for touch events on our table view, for example, scrolling, touching specific cells, as well as tapping accessory items. So we're going to be focusing on the data source protocol for this lesson together, but we need to remember the way in which the data source and delegate are implemented are very similar. So some of the methods that were implemented as part of the data source protocol were number of rows in section and cell for row and index path. We also had some optional methods which included number of sections and table view. And what we're doing here is simply delegating the responsibility of our table view to our view controller using protocols. So if we start by looking at the UITableViewDataSource header file, we see that we have this line of code that says at protocol UITableViewDataSource, and it conforms to the NSObject protocol. Well, just like our classes could inherit from NSObject, our protocols can inherit from the NSObject protocol, which we can guess helps set up our protocol so it works properly. We won't get too much into that. But it's important because it allows us to set up our protocols. We see in our interface for our UIViewController header file, we are also conforming to the UITableViewDataSource protocol, and that name is coming from the protocol we're defining the UITableViewDataSource header file. We also see that we have at required with some methods, number of rows in section, and cell for row and index path, and that we are required to implement those methods inside of our view controller implementation file, or our program will break. We also have an at optional sign here, and these are methods that we can add if we want to change the way in which our table view looks or appears. Specifically, if we want to change the number of sections in our table view, we can implement this method in the view controller implementation file and change the number of sections in our table view. We see that Apple, if we take a look at their header file for UITableViewDataSource, actually has a comment here that says the default is 1 if we don't implement this. So we'll automatically have one section in our table view if we don't implement this method at all. And finally, we see at end, which tells our UITableViewDataSource header file that we're done declaring protocols and we can now go to implement our at interface, which is the standard way we've been implementing our header files. So inside of our header file, we want to take particular notice of our property here. It's non-atomic assign. We haven't seen assign before, but it's just a different option we can have for our property. We're not going to worry about that right now. But we do see that our type is ID, and we've learned briefly about ID in the past. And if you recall, ID is a pointer to an object of type unknown, or an anonymous object. So we don't know what type of object it's going to be, but we do know it'll be an object. And because it's a pointer to type of object unknown, we don't add a char star, because if we had a char star after ID, we'd have a pointer to an object of type unknown. Now this object, we're going to give a variable name of data source, and this data source is going to conform to the UITableViewDataSource protocol. So again, it's a little different. We've never seen a property conform to a protocol, but we're not going to be doing that immediately, but we will be doing that in just a minute when we implement our protocol ourselves. So it's something to take note of, and we'll get comfortable by doing it together. So we see that we're defining this property's value, this table view's data source value here is equal to self. And what is that doing? Well, now the variable data source inside of UITableViewDataSource knows that it has access to the view controller, specifically the current view controller that's setting this property. Right? So we could create theoretically more than one space data view controller, but we only want the specific space data view controller that's setting this property self.tableview.dataSource is equal to self. so that we can pass information back to this specific view controller. So let's take a look at our UITableViewDataSource implementation file, or .m file. Now, it's important to note that Apple keeps the implementation file's code private. And this is for two reasons. First of all, it's proprietary reasons, but also Apple is able to have flexibility. Apple can change the implementation file as it needs to, as long as it leaves its header file consistent, because we will build our code around based on what we see in the header file. But the implementation file, if they need to make tweaks or adjustments, they can. It also gives developers flexibility in terms of building on top of third-party libraries. So it's really important to keep your public API in your header file, and you need to keep that consistent, especially if other people are building on that. But your implementation file, you're free to adjust as you need to, as long as you're not breaking functionality. So here we see that the way in which we're calling the method, or the method number of rows in section, which we're declaring in our protocol, is using self.datasource. And what we're saying is our method number of rows in section is actually going to be declared in the view controller file, the implementation file. And we see that we're going to return 4. And the way in which we're calling this method is not through the self keyword like we've done when we define methods inside of the same class. And we're not creating instance of this class either. We're not importing UIViewController into the UITableViewDataSource and creating an instance of that, because we don't want to create a new instance of the view controller. We want the current instance. So what we're doing instead is we're passing the current instance as a property called DataSource, and then using that property, we're able to call a method in a different class, specifically our view controller class here, and we're able to pass in this parameter. We're able to say for section 0, how many rows should I have in this section? And we return 4. So we now have 4 rows in section 0. So once we have that information, we know how many times we need to call self or row at index path. So here I've written out 4 different method calls to highlight the fact that the method self or row at index path is being called 4 separate times. Now, this would be kind of silly functionality to hard code it this way. Maybe there's a for loop. There could be additional implementation in order to get that method to run 4 times. But we see specifically the method self or row at index path is being passed in 4 times, and we see index path is for 0, 1, 2, 3, and 4. Now, obviously these numbers are a little superfluous. We'd be using an NS index path, and we'd be setting the NS index path's row value to 0. So it isn't quite accurate the way we're using 0, 1, 2, and 3 here, but I wanted to highlight the idea that we're calling this method 4 times, and each time we're passing in a new NS index path object in order to call this method self row at index path inside of the view controller implementation file 4 times. So this method is actually running 4 times. It's not running once and suddenly populating all the information in our table view. No, each time we add a new cell to our table view, this method self row at index path is being called over and over and over and over again. Right? So this is really powerful functionality for us. Because we know this method will be called multiple times, we can add if statements inside of our self row at index path the way we've done in the past, and we've been able to say, like, if index path dot row is equal to 2, do different functionality than if it's index path dot 5, row dot 5 is equal to 5. So that's great. This is how our UITableViewDataSource is being implemented, and it's how it's interacting with our view controller. And we see here that we're able to have another class call back to our view controller class in order to define a method in our protocol, call it dynamically based in a method inside of our UITableViewDataSource implementation file, but then different functionality will evaluate in our UIViewController implementation file by calling back to a different class, and that's why we say that delegates are callbacks. Now there's one other thing we want to cover, and that's how we're going to be implementing our delegate. So we've seen in the past that in order to pass information to a new view controller, we've created a property, and we've set that property's value in our current view controller. So in view controller A, we are able to say view controller B dot property is equal to this value from view controller A, and pass that information over to view controller B. So we were able to see that when we were passing information from our table view controller to our image view controller in order to scroll around on our planet's image. Well, we're also able to pass information back from a view controller to a previous view controller. The problem here is when we pass information back, we're actually deallocating our current view controller, right? So we're popping our view controller off the stack. So the way in which we pass information back to a previous view controller, for example, if I changed my image in some way and wanted to pass that information back, I couldn't create a property of view controller B if I was coming from C, or A if I was coming from B, because I don't want to create a new instance of view controller A. I want to use the current instance of view controller A that's below view controller B, so I just want to pass information back to that view controller that's still being held in memory. Well, I need a way to reference that current view controller, and the way in which I'm going to reference it is using that delegate property. So let's go ahead and we'll see how to implement that in our next few lessons together.